Welcome to SoilStructure software. This is a demonstration of some of the new features we added this year, 2018, and we're going to have 4 features that we'll explain rather quickly. The first one is a braced wall design. How do you design a stem wall if you're only bracing it with a raker? The second one is the silo effect, which is when you have a limited backfill. So you may have a rock face or a soldier beam, and you're building a retaining wall or a basement wall in front of it. The other feature we added is to have a grade beam and drilled pier support reactions. So we have a separate grade beam software and a separate drilled pier support. But if you click on this feature, you'll get the shear, torsion, and the axial load and the bending moments. And then the last feature we added was counting on passive strength from the soil cover above the toe. As you know, ACI does not recommend on using passive resistance above the toe. So with that, let's start on the braced wall design. So let me show you by what I mean. This is a project that we worked on recently. It is an existing stem wall with a footing and a keyway, but the eccentricity was outside the middle third, and it was not passing and sliding. So what we did is we proposed a brace wall onto the stem, and then there is a 5-inch slab. We cleared that, and then we're connecting it to the toe. Okay, so how do you use the cantilever retaining wall software to design this brace? So what you need to do is you go in and you can do some quick hand calcs. Okay, the raker load, factored load, you put the span length, and then you put the support at the footing is location 1, and then the raker is another support, and then you load that with the active earth pressure. So the height is 7 foot 4 inches, and when you do the analysis, you end up getting a maximum moment of 4.88 kip foot. Okay, so then you go into the retaining wall program, and as you could see, this is the general data. Number of stems is 1. So you go to construction, and you could see it's just one stem wall. Okay, that's the stem wall. Okay, then what you do is you click on this, which says stem wall calculations only. Okay, and then you go into not surcharge loads but additional loads and moments. Okay, and then you have to show you this. Okay, right there. And then you say this one, you can call it what you want. You know, I called it moment at brace. You can call it moment on stem wall. Okay, it's very flexible. You can call it what you like. Okay, and its location is 4.33 feet from the top of the stem, and the moment is 4.88 kips. So then what we do is we look at the results. Okay, the earth pressures. Let's see the stem section design. So now we see that the moment demand is 4880 kip foot, and the capacity we're providing is 5178. Okay, and if you wanted to see the chart, then you go and you say, let's see here if I can just squeeze that in. Okay, so you say view one graph, and then you can look at the soil pressure chart. Okay, and you could say you can view at the shear on the stem wall, and you can view the moment on a stem wall. It comes in there, nothing happens at the top until you get right to the brace, and then it's 4.88 kip foot. Okay, and then at the end you can check out your deflections. Okay, all right, so that is the how you design a brace. on the wall using the our retaining wall software. Okay, so now the next thing we want to do is a silo effect, which is when you have a limited backfill. Okay, so let's go back to the software, and if you go to general data, okay, you take out the let's see, let me open a software. Let's not save that. Okay, so if we say stem wall, here it is. Okay, and what we require is that we have to use friction angle and unit weight. So you could either use Rankine method or a Coulomb method. So in this case, we use the Rankine method. Okay, so with that, we say, let's say now that we have a silo effect. Okay, so if you don't have it, you uncheck it like that. So what is a silo effect? Well, let's click on that question mark. Okay, and that's what a silo effect is. You're proposing to build a retaining wall. Okay, and the height of it is the backfill. So it's measured from the bottom of the footing to the top of the stem, or to the top of the backfill soil. And then you have a backfill width. And behind this, there is either a soldier beam or a sheet pile, or you may have a rock face or a very hard clay, and it's already standing vertically. So when that's the case, there is no room for the Rankine earth pressure to develop. It's 60 degrees from the horizontal, and it's restricted either by the soldier beam, the sheet pile, or the rock face or the clay cut face. So in such case, we call it silo effect, and we can reduce the earth pressure that you designed the retaining wall for. Okay, so you go back to silo effect, and then it asks you what is the ratio of the backfill width to the backfill height. Let's say it's 0.5. Okay, so now when you go into the results, okay, so let me go into results, and you go to the silo effect. Okay, and then it reiterates the backfill width of the wall over the wall height ratio is half. Then it gives you a Ka multiplier of 0.85, and that Ka is found in backfill soils. So if you click on backfill soils, this is the friction angle. That friction angle of 27 degrees, the soil or rock unit weight of 118, and the backfill slope of 0 will give you a Ka value here, active earth pressure of 0.319. And what the software does is multiplies that 0.319 with 0.85, and then it designs your stem wall based on that. Okay, so that's the silo effect that you can use. I believe we're the only software in North America that currently has the silo effect on designing retaining walls. Okay, so now we've covered that. The other thing to do, the new other feature is, what if you have a stem wall calculation, but you're not going to use a footing? You want to support it on a grade beam and a drilled pier support. Okay, so now what we do is, let's open another example. Okay. Well, actually, we do have the stem wall and the grade beam already open. So now let's take the silo effect out. We're not going to have that. We need stem wall calculations only. So if you take it off, but we need that. And here is the wall on grade beam, drilled pier. So when you do the wall on grade beam and drilled pier, what happens is on the you're shown. Let's see here. I need to get back to the stem section so you can see clearly. Okay, so it gives you this wall on grade beam and drilled pier. So let's say your grade beam width is 2.5 feet. You enter that, and then grade beam depth, which is the height, is say another 2.5 feet. You enter that, and then you're going to support it on drilled pier. You can change this 2.5 or 3 feet. It's up to you. You can keep it 2.5, and the pier length, let's say, is 25 feet. Okay, Then you choose the drilled pier spacing. Let's say it's 7 feet on center. All right. So now what you do is when you go into the results, right here it says stem wall on grade beam. And what it does is it gives you all the grade beam loads that you need to design. So it will give you the factored shear, which is 24.7 kips, the torsion, 211.7 kip foot, the moment in the X direction, 189, the moment in the Y direction, 17.3 kip foot, and the ultimate axial load. So then you take all these values and you open your grade beam program, if you have it. If you don't have it, you can go to SoilStructure.com and then it will give you that. Also, it gives you the loads for the drilled pier. So when you're designing your drilled pier, it will give you that the service level load is 47.1 kip, the shear load is 15.4, and the moment is 118. So with that, you don't have to determine on the side. You take these values. So let me just show you if you had what our grade beam program looks like. And let's see, I can open it, and it fires up. It checks online, and this is what the grade beam looks like. Okay, so here is the numbers. You'll be given this number, the torsion number, the axial load factor, the moment in the X direction, the moment in the Y direction. You already predetermined your width and the grade beam height. You enter the F prime C and the steel strength FY. Okay, and then you can design and you can have the program check all these, and it will give you green if everything passes. Okay, so that is the thing. Okay, so now, and what if you had a drilled pier? So if you had a drilled pier and you wanted to do the analysis after your grade beam, then our program would open up. Just give it 1 second. Okay, so and this is what it would look like. So we have already calculated for you what the shear load is, what the moment load is, what the vertical load is, and you enter that. Torsional moment is only special cases, like if you have a sine support that's cantilevered. Okay, so this is where you get all of these. So you take all the grade beam loads and you take all the drilled pier loads. And the final thing I'd like to show you is counting on passive resistance for soil cover that's above the toe. Okay, so now let's open, let's see here, file, open, let's save, let's see, so if we opened a, okay, so this is a project we worked on. Okay, I'm trying to fit everything under the window here. Okay, so what happened is this is an existing that's already built. Unfortunately, they added to the height of it without increasing the width of the footing or the keyway, the depth of the keyway. Therefore, the stem wall started to deflect quite a bit, you know, about 5 degrees. So what we decided to do is let's use a 4-foot brace. Okay, that means you add soil in front of the toe. So now instead of having a 9-foot exposed retaining wall, you only have 5 foot exposed. Okay, so what you do is you go to, it's not in general data, but you go into the footings. Okay, you go into the footing dimensions, and you see where it says ignore soil cover at the toe. You don't want to ignore that, because right now we're adding the soil in 6-inch increments to compact it and provide a lateral support. So you say, okay, so let me show you something. I want you to see what's going to happen with the earth pressures. I think that's the most I can go. Okay, so so now when you say, when you take that off, Then well, let me show you here with the pneumatic. Okay, I think that's maybe even better. Okay, so here is the footing pressures. Okay, so let me show you. If you not, this is normally ignore soil cover is already checked. That means we're not counting on it. And at that time we have 1543 bearing pressure at the toe and only 21 psf at the heel. But as soon as you uncheck, now look, it goes to 1605 and 321. So if you were to go into the construction phase, then you're going to see that the bearing pressure is, see if I can reduce it a little more. I want to show you what the bearing pressure looks like. There we go. Okay, so there it is. Now you're counting on it, so you have 1605, 321. If you're not counting on it, you have 1543 and 21. That's one effect. The other effect is the retaining wall stability. Okay, so if you're not counting on it, you have sliding factor of safety is 1.78, but as soon as you say no, I want to count on the soil cover above the toe, then you get 4.97. Okay, and with the overturning factor of safety, if you're not counting on the soil cover, it's 2.09. As soon as you say I want to count on it, it becomes 2.55. So these are the this is the last topic we wanted to talk about. So in summary, you can go to SoilStructure.com, and we have a cantilever retaining wall and the features we added in 2018. And we're not calling this a version 4. We kept it at version 3. So with any existing users, and we're also providing value to new users. Now you can do braced wall design. You can do a silo effect with a limited backfill. You can do a grade beam and drilled pier support reactions. And you can count on the distance of the soil cover above the toe. Thank you very much, and hope to see you soon.